when they lost me, but let's see. All right, we don't want that. And I'm just going to kind of show you what this actually illustrates it pretty well. This goes back to last year and kind of winter we had. What you're seeing here, and this is all courtesy of the Weather Network, by the way. I think it's very, very useful. This is showing you what a jet stream would look like in the month of December, where it's kind of on the mild side. Not much really happens. We don't really get a lot of snow out of this. We get rainstorms that go by from time to time, and that's just about it. You've got this, what we call a zonal flow. Everything moves from west to east. If everything's moving from west to east, you really get cold air to come down, because where's the cold air going to come down from? It's got to come down from Canada, which is up from the north. So you got to get the jet stream to kind of bend a little bit. And that's what happened last year. It did to an extreme way. Now, when you have a jet stream like this, which we may actually have for a brief time in about 2 weeks, after next week, you wind up with a pattern of temperatures across the United States like this, which is everybody except maybe the west coast of the United States has above normal temperatures. Everywhere east of the Rockies, up and down the East Coast into eastern Canada, we're all enjoying some really, really mild December weather, okay? But last year was different. Now, remember this, here's that first jet stream, which is this kind of calm west to east motion. Well, here's the jet stream that we wound up having last year. And you can see the huge difference. Now, I was talking before about those warm ocean water temperatures in the North Pacific. That may play a role in creating this little hump here, you see. That's a ridge, okay? That's an upper air high that's pushing northward up through the Pacific into Alaska. So all the cold air that's up in the Arctic regions and in Canada, what happens to that? Well, it's going to ride the jet stream down the slide and move into the United States. This is what happened last year during the first week of the month of December. If the water is warm here, that may favor a ridge, a high in the upper atmosphere to build up into the Pacific Northwest and on up into the Gulf of Alaska, which would displace all of that cold air. And meanwhile, on the Atlantic side, you had the same thing happening. You have a big ridge building out in the central Atlantic all the way up to Greenland. So what that basically does is it locks the cold air into the eastern part of the United States and into Canada and brings it right down. So the jet stream goes, instead of going nice and flat west to east, now it's going up and down like that. And depending on where those ridges and troughs, where you go up, it's a ridge. Where you go down, it's a trough. Depending on where those ridges and troughs set up, you could be bitterly cold. And this is what happened during the second and third weeks of December last year, where you had this big ridge in the west. So remember, the jet stream moves these air masses along, and you've got this northwest flow bringing all this cold air. So everybody east of the Rockies, the complete opposite of that first thing I showed you, because you have this amplitude. The jet is not running flat west to east. It's running more north to south. So you got all this massive cold air that comes into the eastern part of the United States and goes all the way down into Florida. And this is, again, this is what happened last year. Now, are we going to see a repeat performance this year? I don't know. Still, again, too early in the game. It would be unusual to see back-to-back winters like that, but on the other hand, we had two back-to-back brutal winters, if you remember, 2013 and 14, 2014, 2015. Those were two pretty brutal periods in terms of the weather. Now, I'm going to skip this for the time being. So why don't we go and take a look at what's going to be happening in the short range. Okay, so by the way, if you want to play with any of these weather maps, okay, they're all free. They're all on the internet. This site, I think, for those of you, if you want to look at weather maps from time to time, this is tropicaltidbits.com. and it's great. You every model, almost every model that's out there, and there's so many of them, weather models, you can pull them all up and look at different levels of the atmosphere. And I know that some of this stuff that he's got on there is highly technical. There's a lot of stuff there that I don't get. But there's a lot of stuff on there that is easier to digest, like a map like this. It kind of looks like a map that you would see on a TV weathercast. Okay, so this is actually for tomorrow. Okay, you saw on the radar that had all that rain that was in the southeastern part of the U.S. and that is going to stay there in the Gulf states. So we're going to be dry into early Friday. But notice what happens. Let me just run this backwards. Now I'm going to run it forward. So now we're into Friday morning, 1 a.m., 7 a.m. Friday. You've got rain in the Ohio Valley, rain in the east. You also have some rain down through Texas. See up here all in the blue. Obviously, what is that in the blue? The blue, that's all snow. So it looks like, at least from this model's perspective, that Chicago and possibly Detroit, Milwaukee, Wisconsin, most of the state of Wisconsin getting snow out of this, a good chunk of Illinois, northeastern Missouri. We're getting ready to rain. And because we got this, there's a high up here to the north, the winds here are going to be from the east. So you know what that means. It's going to be very raw and very miserable here on Friday. You're going to have this low run up to the west, very cold air coming into the plains and into the Midwest. But most of this cold air that's coming down is going to go south. It's not going to come, some of it's going to come east over the weekend, but the coldest air is probably going to go to our south and west. So this storm for Friday, this storm system is going to track up into the St. Lawrence Valley. We're going to have a coastal low that's going to develop here during Friday, right here off the North Carolina coast. So we're going to have rain into Friday night. Some of it's going to be on the heavy side. And then if everything moves along, by the time you wake up Saturday morning, it'll be long gone. And then it gets windy and cold during the day on Saturday. And the weekend looks good. But we're setting up for the next one. And here it comes. Now this is for Monday into Tuesday. Now this time it's a little bit colder here as this system approaches. So now we've got a low this early Tuesday morning sitting off the North Carolina coast and running to the northeast. Now look what's happening back through here. You've got, this is all snow here from eastern Tennessee, eastern Kentucky, much of West Virginia, the western half of Pennsylvania, and into southwestern New York. The low is going to move up. This is what the model is saying right now. This may change when we look at this, the next series in about that comes out later on this evening. But this model is forecasting this next system early next week to move up from off the North Carolina coast to about Cape Cod. I will tell you this, if this were a month from now, given that we are in the middle, not even the middle of November, but if we were looking at this during the middle part of December, this could potentially would be an all snow event or a mostly snow event for us. And one of the things I'm noticing is that we've had a series of these kind of systems with lows coming up from the south and cold highs to the north over the last couple of weeks. If that pattern holds as we get into December and January, that could become especially problematic with regards to snow. In other words, we'll get a lot of it. So you'll get snow days. They all perked up when I said snow days, right? You like snow days? That's right, no school. Well, we don't make a habit of that, though. So this is going to move out, and once this low moves out, then we're going to get a shot of pretty cold air here for later Tuesday, Wednesday, and probably lasting into Thursday of next week.
Is that considered a nor'easter?
This would be, I would say you could call this, the definition of a nor'easter has really changed now to cover everything from drizzle to sunshine. As long as it's a northeast wind, somebody wants to call it a nor'easter. But that being said, This has some nor'easter qualities to it. It's not particularly intense, however, but we are going to have a bit of a northeast wind to deal with for at least a short period of time. It's not really a classic type nor'easter though, because the way the low is coming out and where the high is, it's not where you'd want it to be for a true nor'easter. Nonetheless, it is going to cause some problems. But again, if this is the signature, and this is what we look for this time of year, is to see, well, how are these storms coming out? How are they evolving? And if the signature of the storm tracks are going to be to our south with cold highs to the north, when we get into December, particularly when we get to later December, January to February, if this is going on, this is going to be a problem. Okay, and then that pulls out. Now let me go to the upper air because we want to look at the jet stream through all of this because that really is driving everything. Remember the gears that I was telling you about. Okay, we're going to have to give this a minute to load. Yes, go ahead.
What's the classic definition or signs of a nor'easter?
Okay, so when you have, let me get a map up again.
I have a second question.
Okay.
So the jet stream,
yes,
all has to do with water temperatures and airflow. Like what determines the shape of the jet stream?
Everything. The water temperatures have impact. The amount of heating or lack of heating going on in the atmosphere from one place to another drives the jet stream pattern. And the strength of the storms in the upper atmosphere drives it. You name it, there's a factor. It's a lot of factors. And it's kind of like the concept of the butterfly effect, where butterfly flaps its wings in somewhere in the Philippines, and that sets off a chain of events that culminates in an earthquake someplace. There's just a lot of things that go into all of this. I seem to be dealing with a very weak signal because I want to answer your nor'easter question, and it's kind of hard to do if I can't have a map up to illustrate it. Okay, so you know what? We'll try it a different way. I'll use this. Okay, so at least you got the geography. All right, so what you would see in a nor'easter, right up here in this area, I'm moving my cursor here clockwise. So there would be a big high up here. So if the winds around a high are clockwise, so you're going to have, let's say the center of the high is in Vermont. So anywhere south of Vermont, you're going to have the wind going clockwise around the center of that high, and all the winds in this area are going to be coming in from the northeast. So you have higher pressure up here. So now the other part of the ingredient is that you have lower pressure down here. And around that lower pressure, you're going to see the winds going counterclockwise around that low. So let's say you've got a high in Vermont, you've got a low off the North Carolina coast. So down here, you're going to have the winds coming in from the southeast, turning east, and then northeast. Okay? Follow me so far?
Yeah, so basically it's two systems
right.
like that, and they crash, and that's why the system
stalls. Well, what happens is, among other things, so now this low moves up. Let's say it moves northward. The high doesn't get out of the way. Then sort of what you just described would happen. The pressure gradient, so the difference of pressure between the high to the north and the low to the south is going to be very large, particularly if it's a strong low. If you have an intense low here and an intense high here, large change in pressure, relatively short distance, very, very tight pressure gradient, which means your winds are going to be very strong. So when you have that happen for a prolonged period of time, where you've got this high to the north, low to the south scenario, and northeast winds here for hours and hours and hours and hours, that's the nor'easter. Okay, we had that. I forgot what day it was last week. When did we have that last week? Was it when?
Last Friday night into Saturday morning.
Right. I was just leaving for Georgia and drove out of that, thankfully. But yeah, so that would be that was kind of, it was a short duration one, but we did have nor'easter conditions with that. So you can go entire winters, by the way, without ever seeing one. And then, in fact, I can remember last year I had some people. I had someone ask me, say to me, you know, we just don't get nor'easters. This is right before the 4 nor'easters in March. Saying, well, we don't get nor'easters anymore. How come we don't get nor'easters anymore? 1, 2, 3, 4. And I remember talking to that person right after the 4th one and saying, have you had enough now? Because I certainly have. All right. So, you know, again, I think I tried to put up there at least some of the things that we look at with respect to the winter time. With regards to the system for next week, let me pull up. Okay, this chart's going to look a little odd. You're going to say, okay, Joe, it looks like all I'm seeing is bars. I'll explain what this all means. In the meantime, let me just shut this off. Maybe that's interfering with the signal a little bit. I'll get rid of this. Close a few of these windows that might help out. Okay, so when we were looking at those maps before, and we saw all these changes in pressure, these charts are, they are kind of illustrating the changes in pressure that are going on in different areas around the northern hemisphere that are very, very important to us. Okay, the one here in this corner is called the PNA index. PNA stands for Pacific North America Index. So what somebody decided to do was to kind of take those maps that you saw, those surface maps with the high pressure and low pressure, and he says, okay, so if the pressure is high in one place and low in another, let's see if we can come out with a way to measure the relative strength of that. And perhaps it could be a useful tool in storm forecasting. So what we look for is big spikes up and big spikes down. And one of the things that we're seeing going into next Tuesday is in the Pacific North America Index is a spike sharply higher, almost to the top of the charts by the time we get to next Monday and Tuesday. What that is telling us is that in the area where the index is measuring these pressure changes, and I will tell you where they are, up in the Pacific Northwest, okay, and also off the southeast coast of the United States. It's subtracting one from the other. So what this is telling us is that in the west, there's going to be a big high. So if you think that there's a high in the west, there's likely to be a low in the east. It's always got to be kind of balancing it out. If there's a high in one spot, there's got to be a low in the other. Kind of, you know, nature always wants everything like this. It tries to get everything in kind of equilibrium. The problem is, it seldom is that way. There's always something up here, something down here. If something wants to go up this way, in order to make it even, something's got to go down this way. And that's when the atmosphere is out of whack. So that index is actually signaling to us that there's going to be a big change in pressure. And we saw that on that map I showed you before with the storm coming up the East Coast for Tuesday. So that is giving us a signal. The NAO is what we call the North Atlantic Oscillation, okay? Some of you may have seen, whether people on TV refer to it as the Greenland block, okay? What that is a big high that forms over Greenland. It shoves the jet stream way to the south, and we've seen some of our biggest snowstorms under those conditions, and some of our coldest weather under those conditions when we have a Greenland block. Doesn't happen very often, it's rather infrequent, but it did happen last March when we had those 4 nor'easters. We had a blocking pattern in place that forced everything to go further south. So when it's up here in positive territory, you have no blocking at all. What it's telling you is everything in the Atlantic is, the jet stream in the Atlantic is moving right along from west to east and behaving the way it should behave, which is to move weather systems along. And that's what that is signaling. So you've got this index saying that there's a potential for a storm in the eastern part of the United States early next week. That index is telling you that whatever that storm is, it's going to move right along, so it's not going to stall out. There's going to be a beginning, a middle, and an end. It's going to be around for a reasonable amount of time. and then it's going to be over with. It's not going to hang around for 2 or 3 days. Okay. The other index that's important, and it's kind of like the North Atlantic index, is this one down here. I'm not going to talk about this one, but this one down here. This is the East Pacific oscillation, which measures pressure changes where? In the East Pacific, yes. Okay, it's a trick question. I had to throw it out there. When it's down here, very, very negative, that's usually cold for us. That favors the jet stream in a way that it would suggest that we're going to get cold. And you'll notice that starting from today, even though it's not really that cold out, but we are going to be turning a little colder tomorrow, and then gradually turning colder as we go into the weekend. That is way down there in negative territory. But at the same time that thing is spiking up to zero, to neutral, this one's spiking up too. So that supports the idea that we're going to see big pressure changes in the atmosphere early next week that could be for some kind of storm system. In spite of the fact that I'm sure that social media has been on fire telling you how much snow you're going to get in the middle part of November, let me just address the social media issue, okay? Because this is an ongoing problem. I happen to believe that social media is a wonderful tool for communication with regards to weather and other things. But as we all have seen, that it doesn't always quite work out that way. You have to be kind of careful with regards to the sources that you're looking at to make sure that what they're saying makes sense. In the weather world, because in the weather world, Ron, I think you will testify to this, the weather world is dominated by snow weenies. Okay, these are what we call, snow weather enthusiasts. They shortened it to weenies, and then the snow runners, who, as I said, firmly believe that they're entitled to see snow every day from November 1st to April 30th. And I'm thinking, you know what, you can't even see that in Barrow, Alaska, so why are you doing this? But you start to see these maps pop up, these crazy maps with crazy snow amounts 10 days out in advance, okay? Not happening, all right? I can tell you right now, when you look at it, you can see it over the course of the winter, 99% of whatever's put out in the long range in terms of snowfall, when I say long range, beyond the 7-day period, if you start to see these things pop up on the internet, okay, you can kind of wait to do the bread and milk thing, all right? Because that's where it ultimately winds up. I have this general rule. First of all, when I've noticed that in my personal life, that when I'm out in public, and thankfully most people don't know what I do for a living, but you hear conversations that people have. I happen to be a pronoun, but what I mean by that is you'll hear these conversations, well, they said, okay? And remember, I'm they, all right? I'm a pronoun now. So I have this rule, and I will deputize you to, if you want to go ahead and apply this rule. Unauthorized meteorology, okay? You should not tolerate anyone practicing unauthorized meteorology. All right, I will get to that in a second. If, for example, you are in a supermarket and you hear someone practicing unauthorized meteorology, you pull them aside and very gently say, you're practicing unauthorized meteorology. Then reach for something like maybe a frozen leg of lamb, and then just bam. Exactly. I don't mean that literally, so don't go doing that. Okay? But it's frustrating because I actually get to hear what they have absorbed in terms of information, and I sometimes I just like shake my head thinking, where did they hear this stuff? And, you know, with respect to watching TV and getting a forecast, very little information that when you're watching, and we all do it, okay? We all do it. I do it, you do it, everyone does it. You're watching something. You're watching something that requires you to pay very close attention. How much of that information do you actually retain in here after it's done? Not very much. Because when you're asked to repeat it, chances are you're going to probably have already forgotten about 75 to 80%. And, you know, if you're like I am, which is, you know, now that I'm 60, I've probably already forgotten all of it, or just about, because, you know, you can't retain all this stuff. So it's really important on how you absorb the information with regards to the way it's communicated. And social media, you get all this stuff thrown at you. So it's really important you just kind of find, you know, whoever you like as your weather forecaster that you watch, which is totally fine, whoever it is, even if it's not me. I'll live with it. Just, you know, you make sure you take it all. There's a lot of information to take, particularly if you're dealing with something like a nor'easter where you're talking about, you know, if you're talking in the wintertime with nor'easters, you're talking about snow, you're talking about potentially snow or rain. You're talking about, you know, blizzard conditions. You could be talking about flash flooding with rain. You could be having all those things going on at once, plus coastal flooding if you're in a coastal area with tides. That's a lot of stuff to get a hold of. You need to know the start time, the end time, when is the peak. So just try, I think weather.gov is a good go-to source where you can kind of sit down very calmly and sort of figure out from there where you're going to go with whatever decisions you might have to make. I will get to your question in 1 second. There's this gentleman before you, so just hold it right there, or just hold your comment for 1 second. Go ahead. You asked about the Farmer's Almanac.
Accurate or not? Sometimes.
I can't answer that question without giving away who the person that I know that actually puts that together. Okay? The forecasting part of it, look, here's how I would answer this. If I said to you, if I gave you a forecast that said sunny every day for 3 weeks, okay, I stand a pretty good chance of being right 70%, 65 to 70% of those days, okay? That's not you know, the skill score, what we would call a skill score with that. There's no skill in that. It's zero. I'm just telling you the same thing and playing odds. If I know that 2/3 of the days, if I know that 3/4 of the days are going to be dry, and, you know, well, if I'm going to get it 75% right, well, I'll just say sunny, 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 and then, well, I got 75% right. That's a pretty good. That's pretty good. But that doesn't matter. That has no value. So I would answer it that way. You can't look at something 6 months in advance and tell you to the day that something's going to happen. I will credit the person only because I'm very close to that person who was involved in it, who just happened to pick 2 periods last winter that worked out that they were 2 big snow events that we had. So he got lucky. Okay.
Do they use history?
They use some history. They do have some kind of a formula that they use that uses history and, you know, moon cycles and that kind of thing. You know what? If it works, knock yourself out. I mean, that's kind of like how I look at it. If you've got something that works, if it works for you, then go ahead. You know, that's fine. But it's not meteorology, and it's not really weather forecasting. That's correct. Now, I'm sorry. Now you go ahead and what you were going to say. Oh, okay. Boys' room. Go. Go. I'm sorry. I didn't know. You should just go. Anybody else need to go? Here's your chance. Okay. We got some time, so questions. Rod.
So I was going to say, if you're a snow lover, you really don't want to see any snow, significant snowstorm in November, because it usually leads to a
It could be. Statistically, I know that October, there have been very few snowfalls in the month of October, but in the years where there's been accumulating snow in October, most of those winters have been non-events. And I think 2011, 2012 comes to mind with that, which was a big snowstorm for parts of the lower Hudson Valley in Connecticut, where places were without power for a long time. And that wound up being the biggest snowfall of the winter. That was a La Nina winter.
Yeah, even New Jersey.
And, yeah. Just the thing with the November, because that's obviously where we are, and the fact that there's these maps flying around on social media with regards to that. Let me just point out that at least in New York City, which you're reasonably close to, so I think it's kind of comparable, we could use that. So in New York City, in the month of November, since 1960, since 1950, so we're talking almost 70 years of data, the number of times that New York City has had an inch of snow or more during the month of November, 6. So 6 into 70, once every 10 or 11 years. What's my skill score if I say it doesn't snow in the month of November, right? That's pretty good. There's a pretty good chance. I stand a very good chance of getting that one right. Yeah. So you see what I'm saying? If you're arguing that a forecast right now of a big snowfall in the middle part of the month of November goes against so much climate data that we have. So you better have a perfect setup in the atmosphere and a little bit of good foresight and a tiny little bit of guts to go out right now and say that we're going to see accumulating snow next week from that system. I wouldn't do it, not from what I'm looking at now. But that's what the numbers tell you. Yes, sir.
Do you have an opinion on global warming?
Okay, I do. Next question. Okay, so here's my opinion. All right, so here's how I'm going to answer this. Because there's the scientific answer, and then there's the political answer. We want nothing to do with the political answer because that just winds up getting complicated. Okay, and that's not. I don't want to get that part. I don't want to get involved because the other reason is too with the political answer. You're talking about taxes, money, infrastructure. Where do we build? How do we build? Who do we tax? How do we tax? So here's what the story is. So since the end of the mini ice age in the middle 1800s, the atmosphere has warmed. It's warmed about 2 degrees Celsius roughly from the mid 1800s to where we are now. How much of that is part of a natural cycle? Since we were coming off an ice age period, a mini ice age period that started in the late 1600s and lasted through the early 1800s, it would be only natural that the temperatures would be rising, okay? And they'll keep rising until one day they'll stop rising. How much of that is because, well, it's supposed to go up, and how much of that is being influenced by, what we're doing? That I don't know the answer to, and I don't know that anybody does. I think, to be fair, it's foolish to think that we're not having some kind of impact. Everything we do has impact, all right? And I think we need to maybe look at that and see if we can do those things in a better way, in a less, in a less harmful way. Let's use that word. Maybe that's a little strong, but in the long haul, if you're going to dump stuff in the atmosphere nonstop, it can't be a good thing. So the problem is that you've got forces at work whose job it is to basically move money from A to B. And how do we do that? And that's where, we've got one side of the aisle and the other side of the aisle. It's kind of illustrated here, but you follow where I'm going with this. I try to be non-controversial. I try to be Switzerland, Swiss cheese, chocolates, and clocks. And we're good, okay? We wake up, Swiss cheese, chocolate, and clocks, and we're good, all right?
So the hysteria that we hear about, never seeing hurricanes like this before.
That part of it, that gets me upset. You know, that's just nonsense. I live in the People's Republic of the State of New York, which is led by the great Mario Cuomo. I'm sorry, I have memories of Mario Cuomo, by Andrew Cuomo. I have a particular dislike of Mr. Cuomo because he seems to like to throw other people under the bus. And he does it, and he did it a couple of times in a really insidious way, and both times he did it, it came back to burn him. But he said something publicly that just made me laugh. He said, you know, in some that we didn't have these hurricanes back in the 1800s. You know, these storms never happened. And of course, all I had to do was just kind of reach over and pull out my little, you know, history of climate in the United States in 1687 and open up to the 1800s and look and say, hey, guess what? You want to count the number of hurricanes that came up the East Coast in the 1800s? Let's go back to 1821, which I think is one of the hurricanes that came into Sandy Hook from the southeast and basically flooded all of Manhattan Island and New York Harbor all the way up. See, that kind of stuff gets me, and it's not just done by him. I just kind of use that because he should know better to do that, but I understand why politicians do that sort of thing. But, you know, you've got news people and journalists that are just grabbing on headlines and creating this hyperbole that is just a lie, all right? It's just a lie. There have been Category 5 hurricanes before. There will be Category 5 hurricanes going forward. One of the things that's changed, okay? I can remember 1969 Hurricane Camille moving into the Gulf Coast in Biloxi, Mississippi, and producing catastrophic damage there. I don't remember it, you know, physically, but I worked on a special about it 20 years later, so I got to look at some of the things that happened there. The whole infrastructure has changed. Look at what just happened in the area with Hurricane Michael, okay? Which in an area that has never seen anything greater than a Category 2 hurricane come in since 1851. And there's a whole stretch of the Florida coast from just east of where Michael made landfall to around the bend of the Florida Panhandle, not quite to Tampa, that has never seen a landfalling hurricane of any kind. And that's probably because where the coast is and in relation to the Gulf of Mexico and hurricane tracks and so on. So it sort of makes sense. But the fact is that is at least up until now. Michael came ashore in an area where the experience of the prior hurricanes goes back almost 2 generations. So you had 2 generations of people that grew up that never saw a major hurricane make landfall in that area. And they figured, well, you know, we survived all the little ones that we had, so this will be no different. And Michael strengthened to just about a Category 5 hurricane before landfall. But this sort of stuff happens, you know. Thankfully, it doesn't happen very often, but it's happened before and it will continue to happen. Are they happening more frequently? No. But when they do make landfall, they're destroying infrastructure that was not built to hold those, to hold a 155 mile an hour wind and stand to the force of 155 mile an hour wind. If you, there was a thing running around, a story about a guy that built a house. I don't know if you saw the shot on the beach in Mexico Beach of that one house standing up. I actually saw a story that was done. I think the guy explained it, what he did. It was actually really quite interesting. He said it cost him, it basically increased the cost of the house by about 15 to 20% from what it otherwise would be. But it was built to withstand winds of up to 250 miles an hour. There's 2 points that he made about this. One of the most important one is, even though he built this thing and it survived Michael, that still doesn't mean that you stay. When you get the threat, even if you know that your structure can handle you, you need to get out, okay? You just need to get out. Why take the chance? I know everybody's got this sort of emotional attachment. You all have emotional attachments to a home. You don't want to leave it. It's part of who you are. But that's the reality is you need to go because you can replace it. But one point that he made was that the cost of the house was 15 to 20% higher, but he pays lower insurance. He pays lower because he's on the coast, so the homeowner's insurance is off the wall. But he pays lower insurance costs. The way the home was built, is incredibly energy efficient, so he's got lower electric costs. And one thing that he brought up that you just don't think about, we have to also calculate the cost of the time you lose. If you lose your home, you have to spend time rebuilding it. You're losing money. If you've got to take a year or 2 years or 5 years out of your life, and that's not unrealistic in some areas with Sandy, there are still people that don't have their homes back yet. But if you've got to take 5 years out of your life, you got to calculate the cost of that time. And that's billions of dollars when you're talking about a whole population. So these are a lot of the issues that need to be grappled with. And the thing is, how many people are going to say, well, I don't want the cost of my house to be up by 20%, even if it does mean that I'll be safer. You will have people that will argue that. They would rather roll the dice. How do you counter that? I don't know. I'm sorry, I know you said you had a question.
Why is it sometimes when forecasters forecast like a big storm or something like that, sometimes it's a dozen?
Okay.
Like what could happen so dramatically that could change that storm within the say 48 to 72-hour period?
A lot, especially in the wintertime, especially in a situation where you could be dealing with a temperature differential that might be as little as 1 or 2 degrees. Models are good, but they're not perfect. And by the way, the opposite of that question is true as well. You could have the opposite. Right. I will say, and I don't, you might disagree with me, and feel free if you do. Sure. I won't be offended. Okay. I think that the frequency of those kind of situations, while they haven't disappeared, I think they do happen less and less. When we get into the short range, models have gotten pretty good. They're not perfect, but they've gotten pretty good. And even in the longer range, if you think back to where we were maybe 20 years ago, it's pretty unusual to go out 5 days ahead of time and be able to figure out that there was a storm coming. But we seem to be able to be doing that better now. But there's a couple of issues here as well. The zip code issue, all right? Because you're going to ask me how much snow is going to fall at my house by my mailbox to the left side of the driveway, to the right of the awning. You know what I'm getting at here? Right. Yes. So, at the same time, there's a lot of variability, especially in the wintertime with snow. So you're going to, you might have an experience where they're forecasting 6 to 12 inches and say you only get 5 at your house, and maybe somebody gets 15 at his house, okay? That is part of that fluidity that we have to deal with. And one of the things I tell people when, they criticize weather forecasts, and when they make a reference to the fact that weather isn't an exact science, I disagree with that. The rules of science and physics and thermodynamics and how the atmosphere works are pretty much set in stone. It's not that it's an inexact science, it's a fluid science. It's because we're forecasting, we're talking about change, and we're talking about the change of the change. And we have to stay ahead of that. And when you think about the fact that a weather forecaster's job is basically to stay ahead of the change of every single molecule in the atmosphere across the entire world, because one change someplace is going to have impact everywhere else. That's hard. Yeah. Okay, that's really tough. So I would say it this way: it's okay to cut us a little bit of slack. Just give us a little wiggle room, and we'll be fine. I get frustrated sometimes. I want to give someone the answer that they want. I want to give them the person the exact answer. How much snow is going to fall? 13.3 inches. I'd love to be able to do that. I can't.
No, I know sometimes that it all has to do with the freezing point.
Yeah, and it's all going to
moisture in the air and all that.
Yeah, and I would just say.
And there's a lot of variables in that. So
yes.
It's fluid, like you said.
Yeah, I would also just say that we're at a point now where we don't have to rely on supermarket forecasters anymore. And the thing is, if we, it's hard for a storm to happen where unless you're really living in a hole and don't have any communication whatsoever, and never turn the TV on. it's hard to imagine that you wouldn't know one was coming. I will give a big media criticism here because this was a big problem during Hurricane Florence, and I would just kind of jump on this. You guys remember when we get to the hurricane season, but during Hurricane Florence, it's a Category 2, it's a Category 3. Oh my God, it's a Category 4. It's heading to Carolinas. It's a Category 4. It's a Category 4. All right. So what happened? The message. There were two messages with Florence. Category 4 hurricane, epic rains. Okay. Florence becomes a Category 3. Category 2 as it approaches landfall. What does the media do with that? The news media, of which I am a part of, not the weather side of the equation, because this is a battle that we had to fight. The news side of the equation, even before the storm made landfall, the storm is a dud. It's now just a Category 2. Well, guess what? The epic rain part of the equation never changed. That was always going to be there, regardless of how strong it was. And somehow that got lost. That part of the message got lost. And it just, I wish I could have complete control of the editorial control of the news organizations and how they deliver their information, because I would fire all of them. I honestly really wish people would just not watch when they put reporters out standing in 100-mile-an-hour wind. Why? Why? I ask you. You've got sheetrock blowing across your head from every direction. You could easily get impaled by a sharp street sign that has come loose. Why would you even go out there? If it was me, if they asked me, Joe, we want you to go outside, I would say, I'm 60 years old. I've just decided to retire now. Goodbye. I don't understand how news organizations, what value does it have to stick someone out in a place where you have just told everybody that they need to get out? It makes no sense to me.
Then they tell you, don't.
Well, The Onion of weather. That's what those of you who might be familiar with the website The Onion.
Yeah.
Okay. Yeah, I call the Weather Channel The Onion of weather.
And everything on TV now, you got to add a little drama to it. So
Well, because everything has to be taken to its natural Armageddon conclusion.
Right.
Because every day is the end of the world.
But the children here are the ones that suffer, because they're the ones who fear the most.
And you know what, guys? Guess
They
what?
need to know that
It's
they're
been
gonna be
raining and snowing, and we've had big storms, and we've had little storms, and we have all that kind of stuff. When we were your age, and you're going to have that kind of stuff when you guys are our age, or my age, or any age. There's nothing new here, okay? So, you know what? I went to school, they gave me an umbrella, and I walked. And some days they didn't even give me an umbrella, right? So I'm just saying, there's nothing new here. Yes, sir.
Yeah, I'm sorry to say this, but we have to leave now.
Yeah.
But thank you.
No, thank you for coming. I really
Yeah.
appreciate it. Thank you.
Sorry about that.
No, not at all. You gotta go.
Parents are texting me waiting. I don't read them. Thanks.
Thanks,
No,
Cal.
you gotta
Really
go. You gotta
appreciate you
go.
coming.
Yeah, thank you
School
for
day
having us.
tomorrow? Oh, thank you for being here. Thank you. Thank you.
I tried. Thank you. Do your best. Brendan, sorry. Brendan, you want to stay with me? I'll drive you home. Yeah, Brendan, you can stay. Appreciate it.
Any questions from? Why do I know you? You're very familiar.
No,
to
you
me.
look familiar to me.
Watch yourself.
Huh? You gonna walk? You can't walk by yourself. No. Go talk to your mother.
Oh, okay. No, I understand. Did you have a question?
Where are we going, Oz? Yeah, you want to go downstairs? You're not bored? You don't have any questions? I'm waiting for you to ask me a question. You can think of something. No? Not one question?
And there's going to be something.
Right. And look, and listen, admittedly, I had a really tough time with forecasting when I was looking at Michael. I didn't really think, at first, I thought it was going to get maybe, strong tropical storm or absolute minimal hurricane, but not much beyond that. The upper air was just not didn't stand out to me. But you know what? At a certain point, it became obvious that there was something else going on. And the Hurricane Center forecasters had a really tough time with it. It happens, and you know what? That's still, even in this, as good as the forecast has come. One of the things the Hurricane Center said in a conversation that I had with them a couple of years ago with the director, talking about this, and he said, and this is true, when it comes to track, hurricane forecasts have gotten very good. The track error in the landfall of Florence, 48 hours out, was 1 mile. 1 mile, okay? But they will also tell you that they do not have a handle on intensity. The intensity forecast is still something that they're having very, very tough time with because of all the variables that we still don't understand about the dynamics of the tropical system. Yeah. Those are good questions. Yeah, that's not something I get into. You know what? Do they do things to try to figure out scientifically? In fact, I think if you go on the Hurricane Center's website, there is a section that talks about when they did some seeding, okay? And, you know, there have actually been instances where they did some seeding in the Midwest that wound up in a big lawsuit back in the 60s because they created some thunderstorm that wound up like flooding out this other town that, you know, was an unintended consequence. Do I believe that there's some sort of veiled conspiracy going on with weather control? No. I mean, if they're doing it, I always ask the question, to what end? What's the point? You know, I just don't get I just don't get involved in that sort of thing.
Oh, yeah. So you don't think it's really plausible?
Oh, thank you. Thank you.
It's really, really enjoyable.
Thank you.
You don't think it's really plausible? That's like just too much.
I just don't think it's relevant. Yeah, you know what, like with me, I'm a weather forecaster. So that's what I do.
You work for
One. If you have Verizon Fios on
Oh
cable.
yeah, I got Fios. I actually got changed to Fios.
So I do Fios. I do New Jersey News. I'm on there.
You have a card or some reason?
I don't have one with me.
Man.
But you know what? I'm on Facebook. Joe Chaffee.
Yeah, I wrote your name on my down, so I could just maybe Google you.
Yeah.
Because the thing is, I don't want to take too much because other people have questions, but I went to school for meteorology. I've been interested in meteorology since I was like a kid.
Okay.
I'm 44 years old. It's since the mid '80s. Hurricane Helene, I don't know if you remember that storm.
Yeah, sure.
Sparked it, in my opinion. And I was trying to, I don't know, I guess the jobs in meteorology aren't too good, I guess, unless you know somebody, I don't know.
Well,
like anywhere else, but, I'm doing something on the side to try so that my degree doesn't go to waste. I went to Kane.
I know.
And, do you see any meteorological opportunities?
It's very tough. I mean, there are some in private industry. There are some in government. I would suggest you look at USA Jobs.
Yeah.
Because weather stuff does come up. Also, go to the AMS site, the American Meteorological Society site.
Yeah.
They do have job postings there.
Right.
And take a look at those.
Why is it so tough though? Is it because it's like very few
It's
positions, or is it just who you know, or what?
Well, in television there's some, but then there's some also in research. But actually, it's not anymore in terms of who you know, because you know what, you got to do everything on the internet in terms of job applications. No one will talk to you unless you do a job application online.
So, Are you ready? Okay. Well, I'm gonna Google you.
Okay.
So your name is I got the. So maybe I might see an email or something. Keep in touch because you seem like you